Hey guys, welcome again to the set of videos in which I'm introducing vectors. Now, we will in this video introduce the dot product. So the dot product, or it is also called the scalar product. Okay, it's also called the scalar product. Both of these are used. Now let's say that you have two vectors a equals ax, I plus ay, j hat plus az k hat. Okay, this is a j. And say that we have another vector b, which has components bxi hat plus by j hat plus bz k hat. Okay. Now, if I want to take the dot product of these two vectors, now the dot product is represented by a dot. Okay. And in the dot product, what you'll do is you'll multiply the. So there are two ways to define the dot product. So one way, let's look at the first one. It's a b. The dot product a b cosine theta. Okay. So again, it's called the dot product because you have this dot over here. It's called the scalar product because you get a scalar as an answer. The answer does not give you any sense of direction. It's just a number. Okay. So where theta is the angle between the two vectors. So let's say that this is your vector A. Let's say this is your vector B. So theta is the angle between those two vectors. Now, what is the physical motivation of this? When I introduce this concept, students always ask me this question: why are we doing this? Right? Now, there are a lot of quantities in physics that are given by this dot product. So if you think about it, like, philosophically, you have now a more advanced version of a number, right? So all of these are numbers, but this vector is not a number, right? It's sort of like number 2.0. It's like an advanced version of the number. So how do you multiply two vectors? That's the question. So you can multiply two vectors. So there are multiple ways to perform multiplication of vectors. So you can use the dot product, and we'll see that it's a scalar product, and the dot product or the scalar product, and there's another one called the cross product or the vector product, and then there's another one called the tensor product, right? So there are multiple ways to multiply vectors, and where do these definitions come from? They're of course math, but they have physical motivations. They're physical applications of this. Okay, so let's first look at the physical, like some of the examples in physics that where you get the dot product, and then we'll define the dot product in another way. So this is, let's call this definition 1. Okay. Okay. So what are the what is the motivation of this? Now think about a quantity in physics that's given by the dot product. The first thing that you should come to your mind can be, at least it comes to my mind for the first time. This is the work done, F dot D. So the work done is dot product. It's given by this work done is FD cosine theta. Okay. So that's a very good example. If you're doing work if you're applying a force on an object that undergoes some displacement, then the work done is given by the dot product. Another example can be power, which is given by the dot product of force and velocity. So that's so this is like 1, this is 2. So these are two examples. So these have like the dot product has physical applications. It is very important in physics. Okay. Now, coming back to the coming back to the definition of the dot product, there's another way to get the dot product. So let's say that you want to find the dot product of A and B. Another definition is A dot B. Now, the reason I wrote this definition first is because you can see now that the unit vectors, right? These unit vectors I hat, j hat, k hat, they point along the axes, right? So this is your x, this is y, this is z. So I hat exclusively points in the x direction, j hat points in this direction, and k hat points in this direction, right? So these are perpendicular, right? So I hat, j hat, and k hat are perpendicular to each other. So if theta is 90 degrees, you get 0, as the dot product is 0, right? So that's why I hat dot j hat is 0, I hat dot k hat is 0, and j hat dot k hat is 0, because they're all perpendicular to each other. And if you take the dot product, the same unit vector with itself, then you get 1, because the magnitude of the unit vector is 1, right? So I hat is equal to 1, j hat is equal to 1, and k hat is equal to 1, right? So if you take the dot product of I hat with itself, then you get the magnitude of I hat times the magnitude of j hat times the cosine of the angle. So if you're taking the dot product of I with itself, then you get the angle is 0, so you get just 1. Okay, so I dot I is 1, j dot j is 1, and k hat dot k hat is 1. So that's what so that's all about the unit vector. So we need to know this in order to write the next way of defining the dot product. So ax, so when you take the dot product of a dot b, you're going to take the dot product of each of these terms. So this with this, and then this with this, and then this with this. So if you go one by one, so you have ax multiplied by ax. I'm not going to write the ones that are 0. So you get ax bx, and then I hat dot j hat is 1. And then ax by I dot j is 0, so that's 0. I hat dot k hat is 0. So both of these are 0. Okay, so the cross terms are 0. In this similar way, so you get ay by j hat dot j hat, that's 1, and the others will be 0. So the cross terms are 0. So you just get ax bx ay by plus az bz. So that's your second definition of the dot product. So let's look at an example. One way of looking at the dot product also, before we move forward, is that the dot product is the product of the projection of A in the direction of B. So the projection of A, so let's say you shine a flashlight from the top, A makes a shadow, then that's A cosine theta, right? And then you multiply A cosine theta with the magnitude of B. So that's one way of looking at the dot product also. Now let's look at an example. So in the previous videos we did this. Let's stick with this. So we did this example in which we have this vector A, 2I hat, does not have any j component, and B, which is 2I hat plus 3j hat. So if you add the two vectors, you get 4I hat plus 3j hat, right? Now let's take the dot product of these two. So they don't have any k component also, so that's also 0. So the only dot product is a simple example. So this only gives I hat dot j hat, right? So that's so the dot product is just let's write that over here. So A dot B is just equal to 4, okay? Because I hat, so if you want to write that I hat dot I hat dot I hat, right? And then I hat dot j hat is 0. So that's 0. So the other ones are 0 because all of the other components of A are 0. So it's just ax bx, ay by is 0, and az bz is 0. Okay, so you just get 4. So that's your dot product. Now the dot product is really useful if you want to find the angle between two vectors, right? So, so if, let's say you want the angle between A and B. Now in this case it's easy, you know, you can say, okay, the angle between A and B is just the angle that B makes with the x-axis. That's fine. You can use the Pythagoras theorem to calculate that, and you know, sorry, the trigonometric functions to calculate that. But if you want to use the dot product is really useful. Let's say A does not make an angle, A is not along x-axis. Let's say it's along like this, then it's going to be tricky to find the angle of the angle between A and B. So the dot product is going to be really useful because A dot B, right, equals AB cosine theta. So cosine theta is equal to A dot B divided by AB. Okay. Now the magnitude of A, let's write the magnitude of A. So magnitude of A is just 2, okay, because this has an I component. Okay, so A is 2. Magnitude of B is going to be square root of this squared plus this squared. So 4 plus 9, that's 13. So square root of, so if you want to write down 4 plus 9, that's square root of 13, right? So now you just have to plug these in over here to find the angle, this angle theta between A and B. So A dot B is 4 and A dot B is 4 and A, sorry, this is square, yeah, this is 2. So 2 multiplied by square root of 13. So let's quickly use the calculator. So you get 4 divided by 2 divided by square root of 13, and then you do cosine inverse of that, you get 56.3 degrees. So theta is equal to cosine inverse of this factor, and then you get 56.3 degrees. Okay. So in vector analysis, you get you know, question. There are a lot of questions that ask you to find the angle between two vectors, and then the cross dot product is very useful in that. Okay, so that was it for the dot product, and in the next video I'll introduce the cross product. If you like the video, please subscribe, and if you have any questions, post them in the comments. Thank you for watching. Bye.